Well, today's problem is candy, and this is the lead code hard problem, but actually this is very easy problem. So we'll see the problem now. So there are n children standing in a line. Each child is assigned a rating value given in the array ratings. Okay, means like there is an array with a size n, and that array contains some integer value, and those value known as the ratings, the rating of the children's. Okay. So some conditions are like you're given candies to these children subjected to the following requirements. Like each children must have at least one candy. Like every children will get a candy, at least one candy. Okay. Next, children with a higher rating get more candies than their neighbors. Like those children is having higher rating than their neighbors will get more candies. Okay. So what we have to do, we have to minimize the number of candies we have to give. Okay. Well, as we know, the first condition says each child will get at least one candy. So we'll give one candy to each child. Okay. And the second condition says with any child whose rating is higher than their neighbor will get the higher chocolate, means higher candies. So we have to compare the ratings with respect to their neighbors. So as we see, this one is having higher rating than its neighbor, and this neighbor is having one value, one candy. So it should get more than one candy. So that's why we should give two candy to that one, because we have to minimize the number of candies. So that's why we take it two, not three, four, five. So let's see for this one. This zero is having low rating than this from its left side and from its right side. So it will keep remain as it is, because at least we have to give one candy to each student. Okay. So now comes to 2. This 2 is having higher rating than its left side, left neighbor. So we should take we should take more candies for him. Okay. So means 0 is having like one candy, this one is having one candy, so this should have at least two candy. So we should give two candies to that child. So total, how many candies we have required? 2 plus 1 plus 2, 5. As we know, each child will get at least one candy. So we'll give one candy to everyone. Okay. So we'll see here. Like this having low rating than its right side, and on the left side there is no one. So it will get one candy. At least we have to give one candy. So this one is having more value than its left neighbor. So it will get more candies than its left neighbor. So left neighbor is having one candy, so it should have at least two candy. So we'll give two candy to that person. Okay. Next, this one is not having more value than its left because it's equal. We are checking for more rating. So ratings are same, so we don't increase the candies. So candies will remain one only. Well, I hope the problem is clear to you. So let's see the implementation part. Well, most of the people are thinking like to sort the array, then we'll solve it. Well, this is not a correct way. Like if you sort the array, then you don't know like which index, which children is the neighbor of which children. So you lose the index values. So you'll not able to get like which children is the neighbor of which children. So this is not a correct way of solving. So how we'll approach the problem is like first we allocate one candy to each children as the first condition says. So we'll see from left side. So like this is less from its right. Okay, so it will remain as it is. Okay, so we'll go this side. We'll move to this side, and we'll see this one is greater than this 0. So what we'll do, we'll increment it. Next, we'll move from 1 to 2. We'll see this 2 is greater than this 1. Again, we'll make increment it as compared to 1, because it should be greater than 1's value. So 2 should get more candies than 1. So it will get 3 candies. Okay. Similarly, 3 is greater than this 2. So 3 will get more candies than 2, this one. So it will get 4 candies. Okay. So 2 is less than 3. So we'll keep it as it is, and 1 is less than 2. We'll keep it as it is. Okay. So this is the part we traverse from left to right. So let's traverse from right to left. Well, here you can see uh, we'll leave this one value as it is, whatever we are getting here from the traversing from left to right. So we'll leave this as it is. We'll start from here and we'll check like if this index is greater than this one or not, because before we compare this index with this one, we haven't compared from the right side, we just compare it from left side. Now we'll compare from the right side. So let's check this two value is greater than to its right side. If it is greater than this right side, then we'll increment, like it's having one candy, so we'll increment one candy to that and put it here, so it will be having two candies. But before putting two candies, we have to check like this one and this two will get from incremented, like 1 plus 1 from here. So whatever, what if here is value already 3 before, so we should put the 3 only, we should put the greater value only here, whatever the greater value, because first we have computed from the left to right, so that time we will get some values here, and now we are computing from right to left, now we get some values here, so we have to compute the greater one of both. So greater value will be, we'll put here, so here the value will come 2, because here 1 is there, so 2 is greater than this one. Okay, so now we'll see here this 3, this 3 is greater than this 2. So what we'll do, we'll just increment this 2, we'll just increment here in this 2, 2 plus 1 becomes 3, right? It becomes 3. So before putting this 3, we have to check like this 3 is greater than this value which is present here or not. So this is not greater than, so the 4 will remain here as it is. Okay, so let's see for this 2, 2 is less than this 3, so we'll keep it as it is. This one is also less than this 2, we'll keep it as it is. This 0 is less than this one, we'll keep it as it is. From left to right, the maximum, like we are comparing particular indexes from its left side. So from the initial there's nothing to compare, so we keep it as 1. Okay, so we'll start from here. So here we'll check from the its left side, like its rating is greater than this one. Yeah, its rating is greater than this one, so it should have more candies than this one. So initially it's having one candy. Okay, so it should have two candy, right? And then this 2 is greater than this one, it should have more candies than this one, 3. This 3 is greater than this 2, it should have more candies than this 2, so it will having 4 candies. And then this 2 is less than 3, so it will remain as 1. This one is less than this 2, it will remain as 1. So we are done with from left to right. So let's see, because we have seen uh, the maximum candies we are getting from the left side only, like we are comparing it from the left neighbors only. Now we have to compare it from the right neighbors. So for that, we'll compare, we'll leave this as it is because there's nothing to compare on the right side. So we'll start from here to this 2. So this 2 is greater than this one, so it should have more candies than this one, so we'll give 2 candy this side, because initially it's having 1 candy, so we'll give 2 candy. So now this 3 is also greater than this 2, but the tricky part is that it's having already more candy than this 2, like this is having 4 candy than this 2. We'll keep it as it is because it's already more. So now this 2 is less than this 3, will remain as it is. This 1 is less than this 2, will remain as it is. This 0 is less than this 1, will remain as it is. So we'll get this one. So this is the pictorial representation. So let's see the coding part now. Well, we are returning the size of array. So like if the size of array is 0, then we'll return 0 because there is no one to take the candy. And if the size of array is 1, so we'll return 1 because there is only one person to take. So we are making the vector name well, so of the size of array, and putting the value 1 because every children is having at least one candy. Okay, so we are starting it from 1 to n size of array. Okay, means like we are not taking 0 because we are comparing from left side, so that's why we are taking it from 1 because there is no left side. If we do -1 in the 0th index, so it will get -1, so it is out of bound. So we are taking it from first index, so we are comparing like if the current value, the current index value is greater than its left side, so we just increment that value by 1. Okay, so we are done with left to right. Well, here we are starting from the right to left. Okay, because like here we are taking second last index, because if we take the last index then it will go out of bound because of this condition, because we are comparing the right side, right? So what we'll do of the last index, we just store the value of the last index in count, and then we started from the second last index to 0. Okay, so here we are computing with the right side. So if the right side is smaller, if the right side is smaller than the current value, then what it will do, it will put the value of the right side plus 1 in the value. But here's the point, it will compare it first. Like if the value, current value is greater than the right side of value plus 1 of that, so it will put the maximum of that and it will increment into the count. Okay, in last we got our total candies what we have, so it will return the total candies. So what we'll see, like here we are traversing it from 1 to size of array, and here size of array to 0. Okay, so means we are traversing like big of n. Okay, if we take n as a size of array, so the time complexity will be big of n, and the space we are also using here of n size. So the time complexity is big of n and the space complexity is big of n. Well, if you like the video, please click on the like button and subscribe button for such kind of videos. Thank you.